All right, so here we are. You had page 6 for homework last night. I just asked you to do page 7. It was all using your reference table. How do those of you who are here feel about page 7? It's easy, right? Just got to take the time and look it up. I've seen some people try to memorize some of the stuff that's on page 16, or to kind of like, oh, I know what that is off the top of my head and not look it up. My biggest thing is, guys, make sure you look up everything. Don't trust your brain and don't bother wasting your brain space. How often does a teacher tell you, don't do that? It's a waste of your time. Okay, I am telling you, it would be a waste of your time to memorize anything on the back here. Really, all you need to know is what luster means, what hardness means, how you find it, the difference between cleavage and fracture, and basically everything else is right off the reference table. Do not memorize anything back here. So let's go through this. We already did the first two together. So what was the breakage and color of garnet? Fracture and dark green to red. Or sorry, dark red to green, right? See, that's what happens when you try to memorize something that's on the reference table. All right, what about the next one? The characteristics of galena, the luster, and some distinguishing characteristics. It is metallic. And some of the distinguishing characteristics, there's a bunch. So again, how we're doing this, we just go to galena, we find that it's metallic luster, and here's some of the distinguishing characteristics. As long as you put one of these down, I'm good with it. You did not need to put all of them. I should have told you that yesterday. So it's got a gray to black streak, has cubic cleavage and a density of 7.6. Did I talk about that whole density of galena with you guys? No. I didn't at all, right? Who remembers the density of water? 1. Again, do you have to memorize that? No, it's technically on the front page of your reference table. So is a density of 7.6 pretty high then? So what would a density, if you have a really high density, what's that going to feel like in your hand? I actually do feel like we talked about this.
A little heavier.
It's going to be heavy. So here is a sample of galena and a sample of sulfur. If anything, the sulfur is, this sample is a little bit bigger. Skylar, put your hands out for me, would you? We did this, because I remember Logan doing it. So what are your thoughts? Try that again. Okay, this one is so much heavier. Now I remember when Logan did it, he actually said, whoa. And he said, whoa, because it's that much heavier. This silver one, galena, is ridiculously heavy for its size, which means it's got a lot of mass packed into a small amount of volume. That's what's going to give it a high density. So that is the only one they mentioned density for at all on this reference table. And that is a dead giveaway. That and the cubic cleavage. Can we talk about how cubic that is? It's like a little cube. And if you break this, so I just hammered it on the table, take a look at that little piece I broke off. I know it's not, what do you see? You see a little square, a little cube. It breaks. Every one of these broken pieces is a perfect little cube. So that is galena. That's a good dead giveaway for galena then. So it's metallic. So as long as you put any of those, I'm going to put cubic cleavage because it's my favorite part of it. Not going to lie, this is my favorite mineral. Galena is my favorite because, well, first of all, it's shiny. The whole cube thing entertains me, and the whole density thing. Just so you know, fun fact about Mrs. Ritz, she has a favorite mineral. Chemical composition of calcite. So you find calcite, you go to the composition, and I don't know what you guys remember about the periodic table, but remember, if we have a capital letter, it stays capital. If you have a lowercase, it stays lowercase. And if you are a person who writes in capital letters, you can't hear. So if you have to use a true lowercase a when you're writing chemical formulas. That's a big thing next year when you go to chemistry. Lots of people like to just change the letters around. You can't. Capital C, lowercase a is calcium, and capital C is carbon, and capital O is oxygen. You do not have to memorize these. They're all listed down here. So Ca is calcium, C is carbon, O is oxygen. And what was the hardness of calcite? 3. All right, so now for this one, you use these clues to figure out the name of this mineral, and then you look up its use. So first of all, we have metallic. So that first one's metallic. These are our only choices then. Remember, I liked the whole Post-it note situation, but of course, I've lost all my Post-it notes. So I know it's only those guys. Remember, I like to leave the either one open until I figure out that it's not that one. And since it has a color of yellow, is it the either one? Nope, that's only metallic silver or earthy red. Now I know it has a hardness of 6.5, so I get rid of anybody that can't be 6.5. So it's either magnetite or pyrite. Because it had fracture, it's still both of those, but it did tell me it was yellow in color. So I know that this is pyrite. See, I fill in pyrite. And then you go to the uses column. It's an ore of sulfur. So my next question is, do you guys know what an ore is? You do? Does anyone else know what an ore is? Do you know why you know? Who said yeah? It was somebody over there. You don't know why? Oh, okay. Do you know? Do you know why you know? Okay. I'm just curious because I didn't know if they brought it up in social studies at all. An ore of something is if you get this rock out, so if you get pyrite, they can reduce pyrite to pull just the sulfur out of it. So pyrite is fool's gold. So it looks like a giant hunk of gold. Somebody literally asked me, is this gold? I'm like, yeah, I just keep giant nuggets of gold around for everybody just to take. It's not real gold, it's fool's gold. But this is an ore of sulfur, so they will break this down and pull just the sulfur out of it. And you can see how, you know what, I don't actually know that answer. My guess is they probably crush it up and they can, pieces of the iron would probably sink and maybe the sulfur would float. I'm not positive. I know that's how they do some of it. And so they break it down and they get just the sulfur out. Then they use that sulfur for whatever sulfur is used for. And we did that one yesterday. Then they could potentially make sulfuric acid out of it. So anytime you see an ore like this one, magnetite's an ore of iron. So they do the same thing. They get just the iron out of it. And then, so that's really the only use of fool's gold is to get iron out of it. That and to fool a bunch of gullible 10th graders. Continuing on, the next one, if you went through all of that, would have been selenite gypsum. I'm just going to write gypsum. And it is used for drywall. Talc is the next one. It's non-metallic. And it has cleavage. The only one that is used that has all of these things, it would be biotite mica. Which is also non-metallic. Graphite, you can just list all the things for graphite. It's metallic. It has a hardness of 1 to 2. Graphite also has cleavage. It is silver to gray. And it's used for pencil lead. And hematite, that's the either one. 5.5 to 6 or 1. I know that's a big difference, and that's the one that's the rusty one. Hematite has fracture, it's silver or red, and it's again used as an ore of iron, or it's used for jewelry. Sorry if that got a little messy. All right, in a complete sentence, describe how cleavage is different than fracture. How could you say cleavage is different? How about you guys over here? You're awfully quiet. Yeah, thank you. Cleavage has, cleavage breaks with smooth, flat surfaces. And what elements combine to form halite? All you got to do is look halite up. Halite is right there, only NaCl. So you could have either abbreviated it or written it out, sodium and chloride. What elements combine to form calcite? We actually already did calcite up there. So we've got calcium, carbon, and oxygen. And did you guys count how many have cleavage? Yep, cleavage is 14, and fracture? Perfect. All right, on the back of that page, let's go through this the rest of the way pretty quickly. So what is the hardness range on the chart? 1 to 7.5. What's the most common element that you guys found? Oxygen was 15. For the record, the next one was silicon, which was 10. Then if we have the mineral quartz, it is non-metallic, has a hardness of 7. It's colorless, or is it variable? Colorless or variable, there wasn't enough room to write that. And its composition is SiO2. Keep doing this for all of them. Galena is metallic, 2.5, silver, and it's PBS. Olivine is non-metallic, hardness is 6.5, green, and to write that one out is parentheses, FeMg2, SiO4. Fluorite, non-metallic, hardness of 4, colorless or variable, composition is CaF2, and dolomite is non-metallic, 3.5, colorless or variable, CaMg, parentheses, CO3, end parentheses 2. And yes, you have to write it out like that. Can scratch glass, non-metallic, fracture, and is dark red in color. It is officially garnet. Why did I also say you could go with quartz? Because quartz it fits all those things, and it's colorless or variable. That variable means it can be basically any color under the sun. And which mineral can be easily scratched by a fingernail, has cleavage, a metallic luster, and has a black streak? Graphite. All right, that is that. I just realized that we never did page 1 of this packet. Page 1 is literally the definition of a mineral. So we've learned what minerals look like and their characteristics. But now my question is, what the heck is a mineral? Anybody want to venture for that one? Okay, so a mineral is a building block of a rock. That is 100% true. And a very good start, but it is not what a mineral is. Here is the what, not what it's for, not what it does. This is the definition of a mineral. It's a long one. A mineral is naturally occurring inorganic solid with a definite crystalline structure and a specific chemical composition. That's a lot, right? We're going to put each one of those definitions in one of the 5 boxes. It doesn't matter which one you pick. So this is a 5-part definition. Go ahead and put one of those in each of the 5 boxes. It's the longest definition in all of earth science. It's probably one of those definitions. Like, let me ask you this. Do you know what any of that stuff is?
Solid.
Solid. How do you define a solid? No, that's an example. I don't have a great definition for a solid either, but yeah, out of that whole 5-part definition, you know what it means for one of them. You do know what inorganic means? You did learn it last year. Mhm. Darn it, some of you were actually looking at me while I did that. Hoping you, one time you're paying attention. Yes, not, inorganic does mean non-living. So what does naturally occurring mean? Just happens. So let's go through this. So I like that. So let's start with each word. With each phrase or word, we're going to give a very short definition so that you can at least know what a mineral is. So naturally occurring, James's definition was pretty good. It just happens. I just add that it's not man-made. Okay. It just happens in nature. So that means anything that's man-made, what do we know about it? It's not naturally occurring, so it's not a mineral. To be a mineral, it has to be naturally occurring. So anything humans have made is not a mineral. The next one, naturally occurring inorganic, and we already said this one. It means it's not alive, never was alive, never will be alive. Do you guys know what a fossil is? So is a fossil a mineral? No, because it was alive at one point. So even though a fossil is a rock, so in the end you have like a rock that has a fossil in it, it's still a rock, but it's not a mineral because it was alive. This is where earth science makes your head hurt just a little bit. So a mineral has to be both naturally occurring and inorganic. It also has to be a solid, so not a liquid or a gas. So anything that's in the gas form or the liquid form is not a mineral. Those first three are fairly simple, and you as a 10th grade beginning earth science student can figure those out. You think to yourself, well, was this thing made by a human? Was this thing alive? Is it a gas or a liquid? If it's any of those things, then it's not a mineral. The next two, you really have to be a scientist to be able to figure out, or you just have to take the word of a scientist. For example, definite crystalline structure means that the atoms are arranged in a repeating shape. So for that one, you'll just probably have to take my word for it, and I'm taking the word of some other scientist to figure this one out. To determine this, you would need some really fancy scientific equipment that you see on like CIS, where what is it? NCIS, what is it? CSI, sorry, I just put like my father there for a minute. He screws those up all the time. But what I'm getting at, if you've never seen any of those shows, you need the fancy science lab to figure that out. So this is nothing any of us are going to figure out. So definite crystalline structure means the atoms are arranged in a repeating shape. And the next one, a specific chemical composition, means every mineral type has its own chemical composition. But on the same hand, it doesn't matter where you get that mineral from, it will always have the same chemical composition. For example, halite is a great example of this. What did we establish halite is yesterday? Everybody remember? Salt. So it doesn't matter if I get salt from the ocean or salt from the salt mine over in Geneseo, or salt from my table, or salt from the roads, or salt from the salt block you give to animals. Salt is salt and it will always have the same composition, NaCl. Same with gold. It doesn't matter where you get the gold from, it will always have the same chemical composition. So let's play a game. Mineral or not is the game. So I'm going to show you a couple pictures here, and you have to determine, is it a mineral or is it not a mineral? Here's a penny. Why is a penny not a mineral? Because it's man-made. You don't just find these pennies laying, well, you do, but they didn't come from nature. They don't grow on, or sorry, a human had to make a penny. But let's talk about the copper they're made out of. Copper is a mineral. There are copper mines. There's some out west in like Arizona and the states like Nevada out there. There's literally mines where they go and they dig up copper. It's naturally occurring, happens in nature. It's inorganic. It was never alive. It's a solid. It also has a definite crystalline structure and a specific chemical composition. How about this little plastic house? No, clearly the house was man-made. What about the plastic? Plastic is also man-made. Plastic is not a naturally occurring substance. How about a little bit of further education here? Do you guys know what plastic's made out of? Know one of the main ingredients? No, that's different. That would be silicone. Anybody know what a main ingredient of plastic is? It's actually petroleum. Do you guys know what a fancy word? Petroleum is a fancy word for actually oil. Where does oil come from? What kind of fuel is oil? Fossil fuel. So what else do we know about plastic then? If it's made with a fossil fuel, it's not a mineral because oil comes from plants. Keep going. Oh, we got a lot going on here. We got a pencil and a pencil sharpener. Let's break this apart. Are any of them minerals in general?
No.
No, because they're man-made, but let's take it apart. We got the tip of the pencil. Graphite, is that a mineral? Yes, it's naturally occurring. It's inorganic, it's a solid. How about the wood for the pencil? Okay, not a mineral because it was living. What about the metal in the pencil sharpener? Mineral. Almost all metals are minerals. Because some metals, like, is it steel that takes two metals and makes them together and makes this stuff? Is it? Okay. So I'm not positive, but there are some metals that get made out of other metals. What about crayon? Okay, it's wax. So is wax naturally occurring inorganic solid with a definite crystalline structure? No, it's man-made. Motor oil. Not. Give me a reason why. Okay, is it naturally occurring? Oil comes out of the ground, right? Humans don't need to make oil, but they come from fossils. So it's not, there's also a big other reason. There's also a really big other reason this is not naturally occurring inorganic. What's the third one? Naturally occurring inorganic solid. Is this solid? No. All right, the end. So how we're gonna finish up today. I see a bunch of you already packed up, but we still have plenty of time. You guys are actually already ahead because we took the notes on page 4. So if you don't have the notes on page 4, I'll leave these up here so you can grab them. We are going to do another homework assignment.
Sorry, could you say that again?
I will say that again, Siri. This one's a little bit longer. We're going to do page 8. But just because it's longer, it's just as easy. So it's really all we've been doing in lab and putting everything together. So you just go through which mineral it has non-metallic, has a composition of 6, a hardness of 6, white to pink, you'll get the name. Then you can go back in and fill in the composition. So go through using your reference table, page 8. It should be a piece of cake, a little annoying, but you can handle it. And I will put up again page 4 for those of you who were absent yesterday. You're going to want to copy the notes on page 4.